Welcome back to Algebra.js. Today's question is LeetCode 543, diameter of binary tree. So given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in the tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. So let's try and decipher what that means. So we have a binary tree here. We need to work out the diameter, which is the longest path basically. So we have two outputs, so two answers. So we have 4, 2, 1, and 3. 4 to 2 is 1. 2 to 1 is 1, so the total there is 2. And then 1 to 3 is also 1, so the total there is 3. And it's the same with 5 to 2 to 1 to 3. And remember, this doesn't have to go through the root. So firstly, I wouldn't say this is exactly an easy question. It's very similar to binary tree maximum path sum, which is a hard question. So in order to solve this question, we need to work out the sum of the path. And what we're going to be using is depth of search. We're going to use a post-order traversal. So we're going to start from the bottom, and post-order traversal is left, right, root. In terms of the order of the nodes it visits. So we have the left, then we have the right, then we have the root, and then we traverse throughout the tree. So with DFS, we always have base cases or a base case. So let's run through this and see what we have. So we get to this 4, right? Because it's post-order traversal, we're at the left. This is pointing to null in terms of both its left child and right child. What do we need to return up from null? That would be the base case. So if the node we're at is equal to null, we just return up 0. And the reason for this is our output is going to be an integer, so we want to have it as something similar with our base cases. So we're going to return up 0 from these two. 0. We're going to have a variable called max depth, which we're going to update, and this is initially going to be set at 0. So right now we have passed up 0 from both these null values. And we can check at this point whether the current sum of the path, which is left plus right, is greater than the maximum diameter. In which case it's not. So we can look at this value and we need to decide what to pass up from 4. So 4 is going to take in the maximum between the left and right plus 1. So it's going to be 0 plus 1, which is obviously equal to 1. So we're passing up 1 here. And then we traverse down the right side because it's post-order traversal, so we're going down the right. This is going to be pointing to both null values, and they're going to return up 0. We can check at this point whether the maximum path at this level, which is 0 plus 0, is greater than maximum diameter. It's not. So we carry on. So from 5, we pass up the maximum between left and right plus 1. Remember, we have to add plus 1 here because this right here is a valid path. So 1 is passed up to here. So we're at this level now, and we need to do the check against maximum diameter. So the summation of left plus right, whether that is greater than 0, it is, so we can update that to its value. So 1 plus 1 is now the new diameter. Okay, so this is where it gets interesting. So we got to pass up the maximum between the left and right plus 1, which is going to be 2, right? Because it's going to be the maximum, which is 1 plus 1, which is equal to 2. And the reason we do this is because this path right here, which is going up to 1, and this path from 5 going up to 1 are two separate paths, right? A single node can only be touching or can only be directing to two other nodes. Now we go down the right hand side, go to 3, left and right is pointing to null, so that returns up 0. We check is 0 greater than 2, no it's not, so we return up the maximum between left, right, plus 1. So we're going to be returning up 1. And at this point, we're going to get the maximum, which is 2 plus 1, which is 3, so we can update the maximum diameters to 3. And now that we have visited every node, we can just return maximum diameter. So as I mentioned just now, we have to visit each node exactly once. So time complexity is going to be O of n. Space complexity is O of n because we're using a recursive call stack within depth first search, and that is going to take on operation. So as we said, the maximum diameter is going to be initially set to 0. We're going to have the function, we'll call it DFS, and we pass in root, we can call it node. So let's set the base case. So if node is equal to null, we can return 0. Then we need to do post order traversal. So let left equal DFS node.left. Let right equal DFS node.right. So left, right, and then root. We're going to grab the current diameter, which is left plus right. And then we need to update or make a check against the maximum diameter and update it. So that's going to be equal to math.max, current diameter, and max d. And then we need to return up the tree the maximum between left and right plus 1. So whichever one we choose, we need to add 1. And then we just need to return maximum diameter. Okay, let's give that a go. Submit it. And there you have it.